Hello, my name is Keith Simpson, and in this video I'd like to introduce you to a new advance in capnography. I want to show you the setup here and just explain briefly to begin with what we've got going on. So we have here an Anaquin setup, which is a model that we use for ventilation that shows the breathing and rebreathing of CO2. And we've got that fed by a CO2 source from our CO2 cylinder. And as you can see, we're ventilating on Merlin. We've got a very nice, respectable CO2 trace and an expired end tidal CO2 of 43 millimeters of mercury and an inspired of 0. So this is a typical setup for an animal in surgery or anesthesia. And at this point, we'd be very happy about the condition of the patient. What I'm going to do now is just add this amount of dead space, which is about 15 to 20 mils of dead space. I'm going to put this into the circuit between the capnograph and the Y piece and just note the effect on the end tidal values and the outline of the capnogram trace. Okay, so we insert the dead space there, and we were at 43 millimeters of mercury. And of course, with the addition of dead space, we would expect the end tidal CO2 to rise. And of course, we can see it now rising up to 60 or so millimeters of mercury. I think there are 2 points to note, having introduced that amount of dead space. One is that the outline of the capnogram looks very respectable. We still have a normal outline, and we still have 0 inspired CO2. So despite the addition of what is a substantial amount of dead space, we have no inspired CO2, and our capnogram looks very respectable and normal. I'm going to remove this dead space again and go back to our original conditions. And we just let that CO2 return to normal. It should go back to around 45 millimeters of mercury. While that's happening, I'm going to turn on this new feature. So we go into the screen here and turn on the capnography mode, color-coded capnography. Okay, what we now see is a trace that's color-coded as opposed to being a single white trace. Just to explain the color coding, expiration is white, as is the case before. Then the pause is indicated by a yellow coloring of the trace, and then inspiration is indicated by a blue. What we can see here, particularly on this trace here, is how thin that blue line is. So inspiration starts from the very end of expiration, and we see a very, very rapid drop in the CO2 as the animal breathes in and it's replaced by fresh gas. So we would expect to see just a slither of blue at the end of the trace. And the normal degree of expiration is shown by the white, and I say the yellow is showing the pause. Now we're back to our normal 44 millimeters of mercury. I'm going to put the dead space in again and note the effect on the capnograph. So as before, we'd expect the end tidal CO2 to rise, and it does. We're going up to nearly to our 60 millimeters of mercury again, and of course our inspired is still 0. But what we begin to see on the color-coded trace is that the degree of blue is now become much more significant. And we see that, for example, we wait for this waveform. There's a substantial amount of blue here, indicating that we've got a lot of rebreathing. So this blue indicates inspiration. So blue is inspiration, and during inspiration it's high for quite a bit, and it's rebreathing the CO2 into the patient. So by looking at this capnogram, we can tell that there's a significant amount of rebreathing as shown by the amount of blue. If I turn the mode off, color capnography mode off, like that, we're back to where we were before, and as I say, it looks like a very normal, respectable outline of the trace. We've got a normal phase 2, phase 3 and phase 0. That's quite normal and quite acceptable. The only thing wrong with this picture is perhaps the high end tidal value. Put the color-coded capnography back on. And as I say, you can see the degree of rebreathing is the extent of blue. You shouldn't really be seeing any blue in the color-coded trace. I'm going to remove the dead space again, and we'll see the blue will then disappear. So having removed the extra dead space, we should see a reduction in the end tidal CO2. And now we're back to having a very, very tiny slither of blue, which we should see in the normal trace. So this feature not only will identify dead space or rebreathing from extra dead space, it'll also identify rebreathing from causes such as insufficient gas flow or leaking expiratory or inspiratory valves on a circle system. This is a unique feature, but is now being fitted to our Lightning models, and we expect this to be part of production runs in the beginning of the new year. Thank you for listening to the introduction on color-coded capnography, and I'll speak to you in a future video.